Hello, my name's Matthew Rice from Kemtrak, and what we're going to do today is show you how to set up a Kemtrak NBP007. This training is more intended for distributors, and we'll show you how to set up a basic configuration for a new instrument as we would do when the product would leave the factory. Now on the top left of the video display you can see the output from the analyzer. That's what you're seeing here on the display. So whatever you see here, you're seeing, where is it? There. Okay. So what you will need to set up an instrument is a few different things. We need some water, and one of the best sources of pure water is actually battery water. You can pick that up from the local supermarket. It's the stuff you put into irons and radiators and batteries and so forth if you don't want to get any calcium, and it's usually filtered and is extremely low turbidity. We'll need some Nivea hand cream, and again that can be picked up at most supermarkets or chemist shops. And the good thing about the Nivea cream is it's a room temperature stable emulsion, so it's a very stable high optical density material that we use for configuring our instruments. And you'll need some formazine. This stuff can be obtained either from Kemtrak or in this case from Sigma Aldrich. Be careful with this stuff because it's toxic and carcinogenic. A lot of customers don't like having this stuff, but if you handle it carefully, no problem at all. And some film canisters. And these film canisters are what we use for putting in our samples. For cleaning things up, we usually have a little bottle of alcohol here, ethanol, and off to my left some good old tissues to keep things clean, and a spoon. Okay, the first thing we're going to do when setting up a NBP007 is setting the maximum signal. Now, setting the maximum signal essentially adjusts the power of the LED lamps so they won't go off scale. It also sets the range and the resolution of the instrument. Now, we don't want these instruments showing up on site at the customer's place going off scale. We don't want too much light to reach the detector. So for this process, what we do is we use the Nivea hand cream, and this is a really thick cream. They call it cream, but it's you can see it there, it doesn't actually flow. And then what we do is we fill up a film canister with this stuff. You can see it in there. So if you need to get some, just use a spatula or a spoon or something and pop it in there. There we go. So we put the lid on that, and what we do is we punch a hole through the film canister lid so it fits nicely on our probe. And what we'll do is we'll put the probe into this cream. We have a nice little display stand, what do you call a tripod here, but you can use whatever, it doesn't need anything particularly fancy. So we pop that in. Then what we do is we go to the analyzer display, and in the zero menu, further down in the zero menu, it will say set max signal. Now, this is typically something only done once. You generally don't have to do it more than once. And what this does is adjust the power of the lamps so that the unit will not go off scale when placed in this cream. And the reason we set max signal on such a optically bright material is it's guaranteed now to work pretty much on everything. If the customer is measuring something which is just say a lot less turbidity, then I'd recommend you set max signal on their sample, and they'll get higher resolution of their measurement rather. So in our factory, the instrument is set so it will measure this very white, dense hand cream from Nivea. So that's set the maximum signal. You can see it's a bit dirty here, so you just use a Kleenex. And a little bit of alcohol. Just to clean that up. There you go. Now the next thing we want to do is normalize the signal. Normalizing is important because what we want is the instrument to give exactly the same reading no matter where it is, anywhere in the world. So it's a way of making sure the instruments are consistently giving the right number. So we linearize the signal, and for that we use the formazine, because formazine is a standard. It's really the only reliable standard that's available for turbidity. And so long as handled carefully, always wear gloves when handling formazine. Invert the bottle 10 times. Don't shake it too hard because you'll get air bubbles in there and that will affect the measurement. Invert it 10 times. There you go. And make sure it's room temperature. So if you keep it in the fridge, it needs to be stored in the fridge. Take it out the day before you want to use it. So for this, what we'll do is we'll fill up a film canister. Not all the way to the top, because you don't want it coming out. You don't want to get this stuff on the table. Seal that back up again. And then pop on the lid. Then we can put that in here. You can see this one's actually reads, it's 4,000 NTUs. That's what it says on the bottle. I don't know if you can see that. 4,000 NTUs. This has actually been normalized before, so you can see it actually reads 4,000 NTUs. But assuming this instrument was not set up, then you would go into the 0 menu. And again, down the bottom, normalize. Enter. Normalize. And normalize to 4,000 FBU. That's the correct unit. It stands for formazine backscatter unit. And normalize now, yes. So now you can see the instrument reads 4,000. Needs to be shaken a bit, but there you go, 4,000. So now the instrument's set up with the range, which is set max signal with the Nivea cream. So it'll measure all the way from the formazine up to the Nivea cream. And I don't know if you noticed, well, we can show you again, that formazine, which was like milky white, when we put it back into the Nivea cream now, you can see it reads all the way at 51,000. So you know, it's quite a lot more material there that's bouncing back the light. So the next thing we're going to do is show you stray light compensation. Now, the purpose of this next thing is when you put this into a vessel, or there might be some light bouncing back or something, or even within the probe head you might get a little bit of light bouncing back off. So we want to zero the instrument. So for that we use the battery water. Fill it up with water. I'll just give the probe one more little wipe with the alcohol, because when working with oily or creamy substances it can be a little bit stuff left on there. So we're good now. So in the 0 menu you have this thing called stray light compensation. There we go, stray light compensation. At the moment it's off. Stray light compensation measures sort of light, you could say, that's bouncing back from the vessel or from the probe. Inside the probe itself there'll always be a little bit of light that's bouncing back. So we fill that up with water. Water in that. We put that on here. And if you look at the value, it's not 0. You actually get a reading because of the light bouncing from the container and the probe head. So if we want that to read 0, we need to turn the stray light compensation on. Oops, sorry, that's in the 0 menu. Stray light compensation. Here we go, stray light compensation. We turn that on. Now it hasn't been on before. So you can see the value goes to nothing, because it hasn't got the value stored from previous, and it says 0 required. So it's pretty self-explanatory. We need to do a 0, and zeroing is just simply having it in the blend container with the water and just do a normal 0. And what essentially 0 does on this product is just record the amount of light that's bouncing back when there's no sample, and then it subtracts it off the signal. And it usually takes around about 10 seconds. So what it does is it takes an average of about 10 seconds worth of samples, and then you will see, as the name suggests, it zeroes it. Now when working with turbidity, don't be so alarmed by all those decimal places. you really should go in also and change the number of decimal places, because you're looking at noise, and the instrument, I think the specifications is around ±1 NTU on the backscatter probe, so having all those decimal places is just misleading. So you go into display and you can set the decimals on, let's just say 1, and then you get a more useful measurement, keeping in mind that you're normally measuring thousands and thousands of units. So there we go. So that's a unit, that's configured basically to be shipped off.